Hello and welcome to Let's Talk Clean Air. Today, looking at the health of our buildings. Hi, I'm John the Filter Guy. Buildings are under increasing pressure with stricter energy regulations and growing concerns about indoor air quality. The new European standard EN 16798-3 changes how buildings manage air. Whether you own, operate, or design buildings, these updates impact you. Our guest today is going to break it all down, from what's changing to what it means, and finally, what you should do next. Today, it's an absolute honor and privilege to speak to our guest, Tobias Zimmer, Senior Vice President of Public Affairs, Sustainability, and Corporate Communications at Camfil. With over 20 years of experience in the ventilation industry, Tobias is a leading voice in air filtration standards, actively contributing to key international committees like ISO, CEN, and Eurovent. Tobias, welcome to the show.
Hi, John. Great to be here. Looking forward to it.
It's a pleasure. To kick things off in simple terms, considering the EN 16798-3, why does it matter and specifically for building managers?
This 16793 gives you a complete guidance how to design a ventilation system in a new building. So in terms of what is the airflow you need, what is the indoor air quality you need to provide, and what technical parameters, especially filtration, you need to achieve that.
And I understand this is not new. This has sort of been around since 2017. So what would you say the biggest changes have been since 2017 in the latest version?
Well, there's basically three major changes to the 2017 version. First of all, when it comes to filtration, the old standard from 2017 still refers to the EN 779, so to F7 and F9 filtration, while the new one is referring to the new EN ISO 16890, so EPM1 filters, EPM 2.5 filters. That's the first one. And the second one, which has probably the biggest impact on the indoor air quality, is that in 2021, the WHO published a new air quality guidelines with significantly lower thresholds for PM 2.5, PM 10, but also for NO2 and ozone. And these new thresholds are now the base for the limits in the EN 16793, which means the requirements for providing clean air have significantly increased versus the 2017 version. And last but not least, the requirement for molecular filtration has come in. In the old version of 2017, there was a very general statement about that molecular filtration would be beneficial, but it didn't really give you a dimensioning guideline. So that means basically most of the users didn't apply molecular filtration because it was not clearly specifiable with the standard. But that changed a lot because now there's clear limits based on the EN ISO 101213, so clear filtration classes, clear filtration requirements based on the outdoor air. So you have as clear requirements for molecular filtration as you had for particle filtration in the past.
That's fantastic. So it sounds like as we learn more and we study more about the importance of air quality, WHO does their thing and then standards rise to meet that.
That's absolutely right. Because basically the last version of this WHO air quality guidelines was from 2005 and represented in 2005 the latest status of what science knew about what levels of particulates or gases are critical in a room. But of course, over the time, the scientific knowledge changes and develops further. So when in 2021, so 16 years later, there was a new version. Obviously, there was a lot of new knowledge. And this new knowledge led to the point that, especially for particulate matter, the limits had to be decreased significantly. So for PM 2.5, it was actually cut by 50%.
50%.
Yes.
We talked about some of the biggest changes compared to 2017, but what a follow-up question on that is sort of how does that impact everyday building operations today?
It impacts it in a way that if you're in the same place, of course, obviously as before, because your building wouldn't have moved, your requirements will increase significantly. So if you take a typical example, if you would take a normal city in Western Europe, which before was kind of classified as an outdoor air quality 1, which means relatively clean, will with the new thresholds in the utmost cases be classified as outdoor air 3, heavily polluted. without any change in the outdoor environment, just by the new thresholds you have, which means in big parts of Western Europe especially, you will have higher filtration requirements.
So it sounds like they would now have a different, basically just install a different sort of filter level. Is that correct?
Correct. You would need a higher level of filtration, and in some cases, you will even need more filter stages. Because reaching very high levels like a PM180 filtration, it's hardly possible within one stage. And that will be then, of course, a bigger step.
Well, that's quite interesting because in North America, I mean, we don't have that sort of a standard where it's, a lot of people recommend MERV 13. It's kind of a blanket statement, but it sounds like this is more of a tailored approach depending on your building type and location.
Yes, absolutely. The way the standard works is basically in the first step, you classify the outdoor air. So, what is the air quality outside your building? And that is basically a classification in 3 classes. ODA 1, so outdoor air 1, clean, outdoor air 2, slightly polluted, outdoor air 3, heavily polluted. And this is basically really based on the levels from the WHO. If you're below WHO levels, you're obviously in ODA 1 because it's clean. If you're up to 50% above ODA 2, and the last step, if you're more than 50% above the safe limits, that's polluted. And then in a second step, you actually classify the supply air quality you want to have, because not every building is the same. So if you have, for instance, a hospital, you would need rather clean supply air. So a typical requirement would be supply air 1, which requires higher filtration than supply air 2, which would be typical for an office building. And that classification goes down to supply air 5 for places for non-permanent presence of people. Like, for instance, an underground car park. No matter how good you would filter it, the cars inside would pollute it anyway.
So it sounds, would it make sense to say that by having more of that tailored approach per building, you could almost optimize your filtration spend because now you're not wasting money on filters that are way too extreme for the application, or maybe the inverse is true too.
Absolutely. You can tailor it, absolutely. And so you have the right level of filtration, and you can actually also optimize to your needs. Because if you, for instance, have a policy that says the indoor environment is important for you to increase creativity and productivity of people, you can simply specify that in a very simple way, demand supply air 1, and that's all you need to do. The rest, the engineers now know what to do, know how to dimension the ventilation system, how to dimension the filtration to give you good indoor air quality.
Now, I think it's becoming a lot more clear these days that filters have an energy penalty as well. So, how does this sort of fit into the broader European energy performance regulations like the EPDB?
Yeah, in many ways. So, first of all, the 16793 is one of the so-called EPD standards, which is standards which are intended to be used as a technical verification and justification of the energy performance of building directive. So really European legislation. And of course, legislation will never give you precise technical requirements, but it would reference to the set of the EPBD standards where the technical side is defined. And the 16793 is part of the set. So it's part of the definition how a ventilation in an high energy performance building should be.
And so who should be sort of paying attention to, or paying the most attention to these updates? Would it be building managers, engineers, policymakers?
Basically all of
All the
them,
above?
with a different focus, of course. The policymakers have to set up the rules and enforce them. The engineers who set up the ventilation systems, absolutely, because the typical requirement for a new ventilation system in Europe is, if there's anything written in the spec, it will be according EN 16793. So you better follow it, because otherwise you simply didn't deliver a quality product. And for the building managers and for the tenants, it is important for you to keep a filtration on that level, because that basically guarantees you a healthy and productive indoor air quality. So everything below that would be negative impact for the tenants.
Just curious, how would a tenant know? Is it sort of like well or fit well or lead where they have a sticker on the outside of the building? Or, maybe when you're looking to lease a new space, how would one know as an occupant of a building?
The right thing would be simply to ask, what is the filtration level? Is the filtration system according 16793? And if yes, then the owner must be able to tell you what supply air quality is provided, because that's part of the standard.
Makes sense. And I understand that, excuse me, the standard is mandatory for new buildings, but more voluntary for existing ones. So why should an older building maybe consider compliance?
Mainly for the fact that the people in the building breathe the same air as in a new building. So if it is healthy, the health level in a new building, it is the same health level in an old building. It is not mandatory for obvious reasons, because if a building is built and if a ventilation system is built, you may have difficulties to upgrade it. But in the utmost cases, it's absolutely possible, because the main upgrade you may need to do is higher filter classes. And that you can easily do by choosing energy efficient filters. They have this Eurovent energy classification. And in the utmost buildings, you have filter classes C to E used, which means if you would upgrade even to a higher filter class and use energy efficient filters, so A and A plus energy classes, you would actually have lower pressure drops than with the current filters. So you could do both with an optimization. You could reduce the energy consumption and at the same time provide clean supply air and ensure good indoor air quality in the building.
So it sounds like with technology today, you could really have the best of both worlds.
Absolutely, you could.
Would that put a building that wants to attract new tenants to their facility, like let's say an office tower, would that maybe be a competitive advantage for a pre-existing building that maybe being compliant would help them from a business standpoint?
It could, absolutely. Because you have now something easy to reference to, because referencing to a filter class will say nothing to people. But if you simply say you have, out of the 5 supply air qualities, you have the highest supply air quality according latest ventilation standard, that's something that also a normal person should understand. Yeah?
That's compelling. And what are some of the cost-effective ways for that existing building to sort of align with the new standards without a full system overhaul or a retrofit?
It depends a bit on the case, of course, but normally you will have an upgrade of particle filtration, which you could fix with actually going to energy efficient filters. So going from what you have to A and A plus products, which normally should even decrease the pressure drop. If you are in the city center, you may need additional molecular filters, because especially NO2 is a big thing in city centers, nearly in all big cities in Europe. But that you could also fix without a retrofit, because there are so-called 2-in-1 filters, where you can actually have a good particle filter in combination with a molecular filter in one filter stage. So you don't need an actual retrofit, you just replace the current particle filter by a 2-in-1 filter.
Plug-and-play solutions.
Absolutely.
Makes sense. And as far as new construction, what advice would you give to, say, developers to ensure that they're compliant from the earliest stage in that design phase?
Of course, in a new building, you have a bit more opportunities what you can do. And the first thing, as you will for sure have higher requirements in terms of particle and molecular filtration, the first thing for any engineer in that phase will be to make sure that you have enough space per filter stage, so to allow long back filters or longer compact filters, because that will reduce energy costs significantly. And very simple, but still needs to be said, enough filter stages. So if you are, for instance, in a heavily polluted city, technically best solution may be 3 filter stages. And many air handling units today only have 1 or 2. But if you plan that from the beginning, you can be even more energy efficient in that solution.
That's great advice. And switching back to the, pre-existing buildings, many of the facility managers worry a lot about cost. Can meeting this standard actually save money, or is it more expensive in the long run?
It depends on what you look at. If you look at first cost, it will be probably higher, because you will have a higher filter class. But if you look at the total cost of ownership of it, it will be cheaper. Because if you take an energy efficient filter, the energy saving of that filter will by far be higher than the whole cost of the filter. So by switching to energy efficient and good air filters will actually not cost you more. You may even save money by it.
So not only saving money on the total cost, but now you're more competitive, more likely to bring more tenants in.
Absolutely,
So
yeah.
it just sounds like the right thing to do. And but switching from the cost side of things, what are some of the non-financial benefits of upgrading the ventilation, filtration, and so on?
Yeah, the first one is obvious. Fulfilling the WHO air quality limits means you're providing an indoor air quality which is healthy to people. So that means assets below the thresholds of WHO that you can state there's no scientific proof that you have any harm to people by this by the air pollution levels inside, which is exactly the opposite to the old limit. So if you're above, it is technically proven that you have a harmful environment. So health is the obvious one. But more interesting probably to office building owners or tenants in an office building, it is also proven that creativity is increasing by better air quality. Performance is increasing. So you actually get it all. You got improved performance, you got improved creativity, and of course you protect the health of your employees.
Interesting. And I think there was, we had a guest on the show a while ago that did a study. I think it was Singapore, found a 12% increase in creativity just by better filtration. So, I mean, what kind of impact is that going to have on the bottom line if you have
Right.
people working
that
at
will
their
be
best?
much more than the whole cost of your filtration system.
Absolutely. Can this, well, we sort of talked about that earlier, but, I think you agreed that being compliant with the standard would sort of unlock the ability to attract more tenants. Any other non-financial benefits that you would think that kind of come from being compliant?
I think that is the main
Only
point.
one?
Of course, you're also safe for any future legal requirements. And you have to be clear, as soon as you have any deep renovation of your building, it will also apply. You will have to follow the standard. So if you're already before on that level, you're absolutely safe from a legal perspective, and you've done the best for the tenants.
And you sort of touched on earlier the different classifications. You talked about ODA 1 through 3 and so on. How does this standard change the way we classify different air types inside of a building, and why does that matter?
You have basically there classify a few air types. You mean supply air in that case, or?
Yes, exactly. How do
Yeah.
you determine which sort of
Yeah, there's no clear requirement that you need a specific air quality, but there's guidance which is given in a separate document in the Eurovan guideline 423, which gives you typical examples. So basically the standard just gives you 5 supply air classes, from very clean to not clean. And there's the separate document gives you guidance what to choose when, but it's not limited to it. So for instance, the recommendation is for sure a hospital should select supplier 1. But if you have an office of high paid and high creative people, and you maybe even have an indoor air quality policy in your company, there's no reason not to choose supplier 1 also for office people. But supplier 2 would be basically the minimum. Anything below, you're not doing a good job.
right? And this is really predicated on the WHO guidelines. But I'm curious, why do the guidelines suggest PM 2.5 targets, and should buildings voluntarily go beyond the standard to address that?
Yeah, absolutely. And this is actually also addressed in the 16793, because the WHO limits, as you rightly said, are only existing for PM2.10 and PM 2.5 for a very simple reason. The WHO air quality guidelines are based on the scientific findings of the last decade. And to have a proof that PM has a negative impact, first of all, you need to measure in many places on Earth this concentrations, and that's why PM10 and PM 2.5 is measured in most outdoor and indoor stations around the globe. While smaller particles, there is evidence, but there's not so much research yet on it to make it really give a firm limit to it. So that's why WHO said PM 2.5 and PM10.
Right.
But also in writing in the standard, they state that smaller particles, not only PM1, but also ultrafines, have an even stronger negative adverse impact on health. There's not yet a limit to it. And that's how we overcame it in the 16793. We based the thresholds on PM2.5 concentrations, but for supply air 1 and 2, so for very good or good supply air, the requirements in the standards say that you need PM1 filtration, so filtration against particulate matter smaller 1 micrometer, not only smaller 2.5, well knowing that the smallest particles are more dangerous to human health.
So I can imagine that in a few years' time, when there's more research, naturally they're going to update the standard as well, and perhaps WHO is going to have different thresholds as we get more data.
We should expect, but as we've seen, it takes a while to update the standard. So the last one took 16 years. So it may take a while until this comes as firm WHO requirements. That's why we put it in the standard right away, to make sure that when we call something very good or good supply air, that it is all actually very good or good.
And speaking of taking a while, I think this is a first. The fact that the standard introduces classifications for gas pollutants like nitrogen dioxide, which are, as you mentioned earlier, that's found in every major city in Europe. Sulfur dioxide, which is kind of hardly ever more in the oil and gas area or certain countries in the world. And then certainly ozone, which is found in more of the southern countries, if I'm not mistaken. How should a building manager determine if they need gas phase filtration or molecular filtration?
Yeah, actually, it works in the same logic as for particulate matter. So you can basically pick the data from the closest outdoor air station, which normally measures all of these gases. And there's a wide collection of data available on the website of the European Environmental Agency. So you have clear third-party data from a neutral source, which measure exactly the same data points as WHO requires. So you have a clear database, and based on that, you can do selections. And for gases, it's obviously a bit more tricky than for particles, because you will have 3 different gases in the air, and you might be over the limits for 1 or 2 or even 3 of them. And the rule applied in the standard is the minimum requirement is you pick the gas which is the furthest above the limits, so the worst case, and dimension your filtration according to this worst case, knowing that molecular filters normally would work against all 3 gases. So when you pick the worst case and fix the worst case with the filtration level you have, you should have a good result.
And you mentioned earlier that buildings in a perfect world would have 3 stages of filtration. If they don't have the room, is there such thing as a 2-in-1 filter that would have both high molecular filtration or at the PM1 level, but also the molecular side?
Yes, those kind of products exist. You can easily get good PM1, so particulate matter filters, which also have efficiencies against NO2 and ozone of up to 70-80%. So that works. In the utmost cases, it works. Of course, if you have extreme cases of molecular contamination, you may require cylinders, so an extra stage. But the most cases you could fix with 2-in-1 filters if no third stage is available.
And I'm assuming because this is now, it sounds like the first time that molecular or gases have been part of a standard, that there's been enough data over the last 10, 15, 20 years to go, yeah, it actually is dangerous for human health to be exposed to these things. So it's interesting that it's now finally, for the first time ever, into some sort of regulation.
Right. It was a part of that was already in the 2005 regulation, but actually we were missing the right answer from the filtration side. Because there was in 2005 and even in 2017, there was no clear molecular classification existing. So you could actually, a tech guy could dimension the filter in the right way. But you couldn't write in a standard, you need a filter of that type to fix the problem, because there was no classification existing. And now we have with the EN ISO 101-213 a clear classification system for molecular filters, which is as clear as for particle filters. So you can simply write a percentage number in the box and say, if your filter reaches this percentage against that gas, it will fix the problem.
So clarity, sort of clearing the clutter when it comes to determining exactly what you need. more prescriptive. What are some of the most common mistakes that building managers face when trying to comply with the ventilation side of things or ventilation standards?
The first thing is not really looking at the actual outdoor air quality. Because if you don't know what your outdoor air is like, you have no clue how to filter them correctly. And secondly, of course, no clear specification what the supply air quality should be. In the end, it's just two data points you need. What is your outdoor air quality? And what is it that you want to achieve? And if you have these two data points, the rest is basically explained in the standard.
That sounds like a practical first step. Determine exactly where you are and what you want to achieve.
Absolutely.
And I understand that Camfil is actually launching a tool to help facilities navigate that and the different classes and so on. How does it simplify compliance, and where can listeners access it?
Yeah, it simplifies compliance in a way that the standard actually gives you a so-called system efficiency, which means all filters you have altogether should have that result. And of course, for a non-filter expert, that may be difficult to find out what to pick. But with this tool, you simply select a few filters and you get the system efficiency clearly shown. And so you immediately know you fulfilled or you didn't fulfill that requirement.
So in a few clicks, you know exactly where you stand and what you need to do. I've learned that, certainly in the Americas, we use a lot more recirculated air in an effort to sort of reduce the energy footprint side of things, since you're not trying to heat the outdoors. But I understand that's quite a bit different in EMEA. So is there any sort of guidance along those lines regarding recirculation in buildings in this side of the world?
Yes, there is actually a guidance in one of the annexes to the 16793, even if, as you rightly said, we're using much more outdoor air to ventilate our buildings. But especially in terms of COVID, we all learned that recirculation air has a few risky sides to it. And for that reason, there's a new annex to the standard which explains you what to do with recirculation air and how to filter recirculation air in case of airborne pathogens are around. So in case we have a next pandemic, which no one of us hopes, but of course we need to be prepared for it. And so it gives you a clear guidance what kind of filtration you should put in your recirculation air to have a certain level of protection. And what's very obvious in there, in a layman's word, anything below a PM1 filter will not help you to reduce the pathogens in the building. So PM1 filter in the recirculation air in case of you have the next flu season or any kind of airborne pathogens would be basically a minimum requirement to not make the situation worse in the building. And of course, the higher you get, the bigger your protection gets. And if you're up to a HEPA filter, of course, you have medically clean air. Yeah?
And would that also cover, forest fires or wildfires? I don't know if that's much of a risk or if that's a thing that's experienced often in EMEA as it is in the Americas, but would that recirculation component have protection or guidance along those lines as well?
There is no specific requirement for that because basically we have very high requirements for the supply air filtration already because the wildfire will come from the outside.
Sure.
But if you're in such a situation, the same would apply as for viruses. You need a filter with a good efficiency in the recirculation air, if you run recirculation air at all.
Right.
But as we anyway have a requirement to have PM1 filters in the most supply air applications, that should already stop at least a good part of what's outside.
And if you have molecular, now you're getting rid of the odors that are associated with
Absolutely,
that as well. Tobias Zimmer, thank you for joining us today.
Thank you, John. It was a pleasure talking with you.
You can find links and more information about Camfil's new tool in the description area of this podcast. Until next time, for myself, John Holmes, thank you for listening.